Hi folks, so in this video what we're going to be doing is we're going to be completing some exercises based on the topic of the oblique plane. Okay, this is a worksheet itself from the Graphics and Design and Communication textbook and the worksheets that are associated with that, and obviously based on chapter 8 worksheet number 1. Okay, so as you can see there, we're faced with 4 problems on the sheet: 1, 2, 3 and 4. Number 1 and 2, based on what you would have covered in class, should be quite easy to you. I'm going to complete those fairly quickly, and then question 3 and 4 I'll go into a little bit of detail and explanation using the textbook there for those, okay, because they're a little bit harder based on your understanding of the oblique plane. So starting off with question 1 here, so I'm just going to zoom in there, so just moving the object a little bit more into focus there. So it says here, the plan of an object resting on an oblique plane is shown. On an oblique plan is shown. Complete the elevation. So you can see here we're given the vertical trace and the horizontal trace of an oblique plane, which is where it's obviously cutting the vertical plane up here, the horizontal plane down here. Where the oblique plane cuts through, it leaves behind the traces: vertical trace, horizontal trace. In the plan view, you can see we're left with a regular pentagon. Okay, and we have to get that essentially, what does that pentagon look like when it's up here in the elevation? Okay, so this is simply point location. Anytime we're given the plan, what we're going to have to do is we're going to be using horizontal cutting planes, which will leave behind a trace on the oblique plane as well. So parallel to the horizontal trace, I'm just going to check what angle that actually is at. I might have to use set squares. It's actually working out perfectly, so just zoom out there so you can see that's actually working out perfectly with my 60-degree set square like that. Okay, so it's after making my life a little bit easier. So from any point that's down here, I'm going to label them, starting with number 1, 2, 3, 4, and 5. If I want to find point number 1, simply what I do is parallel to the horizontal trace. Now in this case it's working out at 60 degrees, but parallel to the horizontal trace, okay, I'm going to project up there until it hits the XY line. Where it hits the XY line, I'm going to go vertical, and then where it hits the vertical trace, go horizontal. And now to find the exact position of number 1, normal orthographic rules apply here. 1 in plan has to be directly above it in elevation. That's where point 1 is in elevation. So just to recap that step, I'll do the exact same for point number 5, which just happens to be the next one in line. So from number 5, parallel to the horizontal trace. Okay, sliding set squares if it's not working out perfect for you, obviously it's 60-degree angle. Then project up vertically where it hits the horizontal trace, up vertically to hit the vertical trace. Project across, and then from where point 5 is in plan, project up, and as you can see there, just have to bring my line slightly further across. Okay, so there's point number 5. Now what we want to do is we want to do the same method then for number 2, 3 and 4. So to save me time, I'll do them all at once. There's 2, there's 3, and finally number 4. So if I want to find number 2, 2 will go up. In this case 4 will go up, and finally in this case 3 will go up. And then I should actually project up number 2 here from the plan, because I can see exactly how high I'm going to need it. Number 3 is always up here, and finally number 4. And number 4 is up high enough as well. So number 2, simply going to go across to there. So I'll label it while I have it. There's number 2. Number 3 will be right here. And finally, the last one I want to find is number 4. There's our number 4. Okay, so as you can see there, that's our structure. So I'm now going to heavy in that. 1 to 2, 2 to 3, 3 to 4, 4 down to 5, and 5 back to 1. Now, that's what our pentagon looks like, obviously in elevation. Now, based on the actual drawing there, I'm just going to put in what maybe the 3D might look like. So I'd imagine 1 is going down to the ground. Might see number 5 there with an edge running down. Number 4. I'm drawing in the elevation view. And then obviously if we're looking in this direction, I can see edge 1, I can see edge 5, I can see edge 4, I can't see edge 3 and 2. So let's say number 2 then will be hidden detail. And obviously number 3 might be in hidden detail at the back. And then just going off the color that they have here, yellow, just going to, as quickly as I can, just shade in using my marker here. Try and go over all the edges. So there's that surface that's been cut by an oblique plane sitting in there. Okay, so there's our object. Just heavy in that edge a little bit further. There's that first edge. Okay, so that's simply a point location exercise where when we have the points in the plan, we project parallel to the horizontal trace to hit the XY line. Where it hits the XY line, we go up vertically to hit the vertical trace across, and then project up the point from the plan to locate it in elevation. Okay, that is technically when we're using horizontal cutting planes. Okay, now I'm after putting in the object there. I won't do that maybe for everyone in this exercise, but because really all we actually had to do was find what the pentagon looks like in the elevation. Okay, but I'm just after imagining maybe what the 3D object did look like. Okay, so what we're going to do now, moving over here to the right hand side of the page. It says here, given the plan of an object resting on an oblique plane, also given is the elevation of a point P, which is obviously point on the object. Okay, we have to find the vertical trace and complete the elevation. Okay, so in this one here, we can see we've been given the plan, we've been given the horizontal trace, but we're not given the vertical trace. Okay, so we can actually use, if I just come back here, I'll put the two of them into focus, we can use the method we've applied here previously to find the vertical trace here, but just by going backwards. So if you imagine here, we've got obviously P1 down to P. We've got the elevation view of P, which is up here, they're calling it P1. Let's just call it P, okay? Now, if we applied the same principle over here, watch this, we've got the point. So from 5, obviously 5 is down here in plan and 5 is here in elevation, like we have P1 and P in plan, okay? Obviously, from 5, somewhere across here to the left is a point on the vertical trace. So from P1 there, obviously there'll be a point going across here that would be somewhere over there, I assume is going to be the vertical trace, okay? Somewhere along there. Don't know exactly where, I have to find it, okay? Now, where it hits the vertical trace, it goes perpendicularly down, okay? So, perpendicular to the XY line down. Now, we don't have that point, so we can't go down just yet, okay? But where it goes down and hits the XY line, that point is connected back to 5, okay? And what's the relationship between that line there and the horizontal trace? They are parallel. So likewise with the horizontal trace here, what we're going to do is we're going to go parallel from P to the horizontal trace. Once again, just going to check the angle. It might work out. No, I'm going to have to maybe use a little bit of sliding set squares here. So I'm using sliding set squares parallel with the horizontal trace from P, sliding set squares. Where it hits the XY line, you can see here we're making that shape. So from 5, we've gone parallel where it hits the XY line, and we're now going to go up. Okay, so this is just working backwards. We're now going to go up. Okay, and previously, if you look at the steps here, making that shape there, where we went up, parallel to the horizontal trace, up to hit the vertical trace and across to locate point 5. In this case, we're trying to locate a point on the vertical trace. So parallel to the horizontal trace, where it hits the XY line, project up. From point in the in the elevation, project across. And where the two doors cross there, I've now found a point on my vertical trace. So now that I've found a point on the vertical trace connecting to T, I can draw in that vertical trace. Okay, so that's applying the same principle, only working backwards. So now, having done that, I'm just going to bring that into better focus there. Now what we're going to do is we're going to find the rest of the points here. So, we're given a semicircle. Anytime you're given a semicircle or something circular in your plan view, you may have to break it up into multiple points. So I'm going to break it up into 30, 60 degrees to help me locate further points. So 30 degrees to the left, 30 degrees to the right, 60 degrees to the right, 60 degrees to the left, and vertically up. Okay, now if this is P, I'm going to say this is Q, or S, T, I'm going to say U, and V. So I want to find all of those points. So, simple point location exercise now. Parallel to the horizontal trace. So I'm going to set up my set square so it's parallel with the horizontal trace. So if I want to find Q, or it looks like these two are going through the same one, so that's helpful. Then finally U and T. Okay, for every one of those hits the XY line, I'm now going to project upwards to hit the vertical trace, which is what I'm after finding. As you can see there, just have to extend on my vertical trace ever so slightly. Okay, now if I want to find those points, so I'm going to start off, we've obviously already got P. If I want to find Q, so Q is up there somewhere. If I want to find R, up there somewhere. I want to find S, up there. I want to find V, looking at it there, a little bit higher. And finally, if I want to find T, it's up there, and likewise with U. Okay, so starting off with Q, comes across, I think it's that one there. So looking up here, in this case we'll just call it Q1, we'll go with the same pattern that they've done. Next one I want to find is R, label it, R1. Next one I want to find is S. Now in line with the S is the V as well, so I'm going to mark it out there as well. So there's S1 and V1. Then finally U and T at the very, very tip top. So I've obviously got U1 and T1, and connecting from V to P is a straight line, or in this case V1 to P1. So go heavy in that. Okay, and as best I can now, I have to freehand sketch my curve. Okay, so I'm going to start ever so lightly. Now it's obviously going to go a little bit up, before I go down to S1, R1, down to Q1, and into there. So now that I have the curve, I'll sketch that in. Try to make sure that your line looks like a continuous path, it's not all hatchy. Okay, I'm using pens here, so it's not the best. Okay, there you have it. There is the elevation view of our structure. Once again, just use a little bit of colour. I'll only use it on the perimeter this time. Just identify the area. Okay, so there is our structure. While I'm at it, I'll just keep having it in actually. Apologies. My marker doesn't run out. Okay, there we go. Probably not shaded in as nicely as I did this one over here. Markers are slightly running out, but that's the first two questions completed on that exercise. Okay, so the next problem here we're faced with on the bottom left is a little bit trickier, as is this one here on the bottom right. So just going to read the question here. I'll zoom in on it. Okay, so it says here, given the elevation of an object resting on an oblique plane, The plane makes a true angle of 60 degrees to the vertical plane, complete the elevation. So if you actually look at the previous questions that we did, obviously in the first one was just point location, the second one we had to find the vertical trace. You can see here we're given the vertical trace, we're given an object, okay, kind of like a quarter of a circle, okay, with a concentric one inside of it, so a quadrant. And what we're obviously going to have to do is get this object down here in the plan, but we're obviously also missing the horizontal trace. But they do give us a little bit of information. The information they give us is the plane makes a true angle of 60 degrees to the vertical plane. Okay, that's the information that they give us. That's going to be quite helpful. Okay, we have to use that information to find our horizontal trace. So given the elevation of an object resting on an oblique plane, the plane makes a true angle of 60 degrees to the vertical plane. Okay, so I'm just going to bring us in here. I'm going to zoom in, and something that we've covered previously in the class, the true inclination of an oblique plane to the vertical plane and the horizontal plane. So in this example, it's actually in relation to the horizontal plane, but I'll go over, okay, in a second to explain the vertical plane. So what we're trying to find is, you can see here this little symbol inside in here, little alpha symbol. We're trying to find that angle there, okay, and this is the solution. We're going to be using the semicone method to help us out. To find the true angle, insert a half cone or a semicone underneath the plane and tangential to it. The base of the angle of this cone will be the true angle of the oblique plane. So, step number one, what we're going to do is draw a vertical line AB. Okay, now in this case, we're going to have to be working backwards, so it mightn't always be the case. So we're going to be using the information that they've given us in the question, where we're going to be using 60 degrees to the vertical plane. Okay, that's what we're going to be using to help us. But essentially the method is this. We're going to put in a semicone in here. Okay, now in the horizontal, or sorry, in the plan view down here, what you can see is from the apex of the semicone, okay, or what's known as the axis there, the apex is obviously point A. This is the axis running down through it. But you can see this line here in regards to the horizontal trace. This line is perpendicular to it, that little symbol there, okay? And essentially what that line is representing is this line here from A all the way down here to C. That's like a generator of a cone, okay? In the plan view, we're going to see that just as a line, okay? Now what's going to happen is, that is, as we're looking in along the horizontal trace, that's actually representing this angle inside here. As we look in from this direction, it's going to show us the true inclination of the oblique plane in regards to the horizontal plane. Okay, very, very important. So if we look in along that, now what we do with that angle though is, instead of actually looking in along it, which would be an auxiliary, okay, what we're going to do with that angle is, we're actually simply just going to rotate it all the way around here until it hits the XY line. So that rotation in the 3D looks like this in the 2D. From this point here, rotate it until it hits the XY line and then connects that point there, because this is still the generator of the cone. This line here is the same length as this line, is still the generator. That point there then connects up here to A, the apex, and that shows us the true inclination of our cone. Okay, in regards to this, it's actually showing us the true inclination of the oblique plane in respect to the horizontal plane. Okay, so that principle is what we're going to be using. Now on the next page, this is the one that applies to the question that we're doing. So in this case, it's in regards to the vertical plane. Okay, so you can see here, we've obviously got another semicone. This time it's sitting obviously kind of flat down on its body. Okay, this is the ground. You can see the apex here, which is A, which is positioned over here. We've got the axis from A to B, which is here in the plan view. Okay, and it's obviously from here in the 3D. We've then got obviously a generator of the cone, which we're seeing from A to C here. Okay, that's the generator, and in the elevation view, this is how we see it. Now, very important to note that that line right there, okay, that one there is the one we're going to be using. It is perpendicular to the vertical trace. Very, very important. So we can set up that cone anywhere as long as it is perpendicular to the vertical trace. Once we have that done, what we're going to do is we're going to rotate it down. Okay, we're going to rotate it down, and you can see then where it connects back to the apex, that's a point that is on our horizontal trace. So we're going to apply that. Okay, what we're going to do, the plan makes a true angle of 60 degrees to the vertical plane. So we're going to use that principle to find a point down here on our horizontal trace. So what we're going to do is, from our XY line, we're going to go perpendicular to our VT. We're going to rotate it down, and they tell us this angle. In this case, they just say alpha, but they tell us that it's 60 degrees. So from this point here, we're going to go 60 degrees until it cuts the line going down. And that point then will be on the horizontal trace. So really, really tricky stuff in that part there. So, as I said, we've got a vertical trace here. Just going to check the angle that it is. And in this case, you can actually see, if I zoom out there, it's perfectly 30 degrees. Okay, so to go perpendicular to that, it's really easy for me just to use a 60-degree line like this. Okay, I know it says 60, so I don't want you to get confused there. What's important here is that we've gone perpendicular to the vertical trace. Now that we've gone perpendicular there, what we're simply going to do, zooming back in here, we're going to take this point here, which is like the apex. Okay, and we're going to rotate down like this. Now, essentially, all we've done is we've gone perpendicular to the vertical trace and rotated. If I go back to my explanation here, we've gone perpendicular to our vertical trace, rotated. We can see here where this point is, we have to project downwards, and they give us the angle here of 60 degrees. So now we're going to project downwards in the plan view. And then they tell us that the angle is 60 degrees. So from here, I'm going to go at 60 degrees at this point. And where that cuts through, right there, is a point on my horizontal trace. So that's how we're using the semi-cone method to work backwards. Really, really, really higher level stuff there now. Okay, so that there is my horizontal trace. Okay, now that I've got the horizontal trace, it's simple point location to complete the rest of the exercise. So you can see here we're kind of given a quadrant. I'm going to go from the center point here, 30 degrees like this, and from the center point, once again, 30 degrees. That's right, 60 degrees in that case. And what I'm going to do now is, using, if I can find my pen, I want to use numbers. So I'm going to say 1, 2, 3, 4, 5, 6, 7, and 8. Simple method here now. Okay, with all the points in the elevation, so we're going to go parallel from every point to the vertical trace. So I'm going to start with the one that's closest to me, which is 8, parallel to the vertical trace. The next one that I'm hitting with seems to be 5 and 7. It's very handy when you can get two at the same time. Then I've obviously got number 1, number 6, number 4 and 2, and finally number 3. Okay, where every one of them is, I'm going to project them, hits the XY line, I'm going to project them down to hit my horizontal trace which I've found. Okay, and then finally, if I want to locate those, I'll actually just use this as a guide. So if I just say this is where number 3 is, I sometimes do this. This is 4 and 2, or I should say 2 and 4. The next one I have is number 6, right there. Next one after that I have is number 1. Not to get confused, it's actually here. There's number 1. And then I have 5 and 7, which is right there. And then finally number 8. Just to give me a little guide. So starting off, I'll go with number 1. Just so I can see how far I have to bring it down. Go to number 2. That's 2 and 4. Go to there. Number 3 doesn't have to come down too far. Okay, so 1, 2, 3, 4 done. 5 kind of is in line down here. 6 to about there. 7 to about there. And finally 8 is the lowest. Okay, so to find those exactly, here's number 8. Then we'll go with 5 and 7. So you can see why the numbers are helpful here now. So there's 5 and 7. and then we're going to look for number 6. We brought them across, yeah. So there's number 6. Okay, now we're looking for obviously 1, 2, 3, and 4. So if I start with number 1, so there's number 1. Then I've obviously got to look for number 2. And I think number 4 is on the same line, so I'll bring this all the way across. 2 and 4. And then the last one, number 3. I can see there, number 3 is right here. So, at this case then, 1, 2, 3, 4 is all a curve. So as best I can, I would sketch that in. So nice and light first of all. 2 to 3. 3 is going to go all the way around then. So it might go up to go down to number 4. And likewise, 8, 7, 6, and 5 is a curve. Extend it on over and down. Now 1 to 8 connects as a straight line. 4 to 5, straight line, and then it's a case of heaving in that curve. Okay, so the point location is the easy part. The hard part in this problem was obviously getting our horizontal trace, applying that semi-cone method. Okay, so they gave us the angle, we had to go and apply it. And you can see there, we've now got the plan view, what looks like a perfect, obviously, quadrant of a circle. You can see what it looks like in plan. Okay, now I'm just going to highlight, I'll actually use a blue. Okay, the method we did there. So from any point there, it didn't matter where, I went perpendicular. Okay, then simply that rotated around. Let's put a little arrow in there. Okay, and then from here, once we rotated it around, what we did was we went at that angle in there, which they told us was 60 degrees. And then from this point here, we went straight down. And that helped us locate that point. Okay, that's the bit that was important there. Okay, to help us find a point on the horizontal trace. Now that we understand that, what we're going to do is we're going to try and apply that to the next problem as well, only it's working the opposite way around. Okay, so here's the next problem, last problem on the sheet. So it says here, given the plan of a figure resting on an oblique plane, the plane makes a true angle to the horizontal plane of 35 degrees. That's what it should have said there. It should say horizontal plane, like we had over here where it says the vertical plane. Okay, so same principle that we learned previously, only in this one, if I go back in here, that was the one where it was in the vertical. This is the horizontal one. So this is the exact method we're going to be applying here. We're going to go perpendicular to our horizontal trace. Going to rotate it around. Doesn't matter which way we rotate, absolutely fine. I can either rotate to the left or rotate to the right. And then using this point here or this point, I'm going to use the angle that they provide us with. And in this case, the question actually states that it is 35 degrees. So using the horizontal trace here, I'm just going to check once again if it lines up with any angle. It almost is, but it's just a little bit off. So it looks like 45 degrees, but it looks slightly off. So what I'm going to do now is just using a method I often use in class, get my 45 degree set square, put in the long edge, and if I rotate it that way, I can now go perpendicular. So step number 1, perpendicular, does not matter where. Actually come a little bit out here. That's step number 1. Perpendicular. From that point there, I'm going to go and rotate it in this way. And then what we're going to do is we're going to do a line at 35 degrees. So using our protractor. And from here, 35 degrees, 10, 20, 30, 35. There we have that. And then obviously from this point here, which is technically the apex, cone, sorry, that's actually the ground, the apex up there, but this point right here is a point on our vertical trace, and I can now draw that in. There is our vertical trace, or VT. Okay, our vertical trace. So what we're going to do now is we're going to use simple point location to get the cut surface here of obviously something I'd assume that is a cone. Okay, so once again, just going to highlight that in the blue, just follow the method, use the semi-cone method. We went perpendicular there, rotate it around. Okay, then having rotated around, this angle here, really important, and then perpendicular up from the XY line, or vertically up I should say. The angle here was 35 degrees. Now that's the method we used to find that, okay, and we did the exact same over here. Now what we're going to use is point location to complete this cut surface down here. So in the plan view, we've already got this cut surface, this circle here that we can see. So normal, what we're going to use is orthographic rules. We're going to split it up into 30, 60 degrees to the left, 30, 60 degrees to the right. Going to go horizontally across, and then 60 degrees this way as well. Okay, so that one's done there. Now what we're going to do is just using normal numbers, okay, like a clock. I'm going to say this is 12, got 6 here, 3, 9, and obviously fill in the rest then, 1, 2, 4, 5, 7, 8, 10, and 11. Okay, I want to find all of those points. I've got them in the plan, so I'm going to go parallel to my horizontal trace for every one of those. Now, hopefully, yeah, so 7 and 8, you can see here is on the 1. Got 6 and 9. I think on this one they might actually all work out. 5 and 10. Page get caught there slightly. Then I've got 4 and 11. Got 3 and 12. And finally 1 and 2. Okay, for every one of those hits the XY line, I'm going to project it up vertically until it hits my vertical trace. Okay, and now it's simply a case of actually trying to find those. So what I'll actually do now this time is I'll just bring all my, where every one of them hits the vertical trace, just bring them all across, have them ready to go. Okay, now if I want to find, starting off maybe with the highest point, number 12. 12 is probably what I think is the highest, I should say. There's number 12, and what's with number 12 as well is number 3. So that'll be on the same line. Just to show you how I figured that out, there's 3, there's 12. So follow 3 and 12 up to here, hits there, the vertical trace, and across. Next one I'm going to find is 1 and 2, which is the next one up from that. There's 1, and there's 2, and there's 1 and 2. So obviously then I'm on to 4 and 11, which is most likely, if I follow it across this one, yeah, it's the next one down. So there's 11, and there's 4. Okay, next one down then will be 5 and 10. I'm assuming that's the right one. Now I'm just following the pattern, but I'll just check it. Always check to be sure. Yep, so I know I'm on the right line. Then we're on to 9 and 6, because they're in line with each other here. There's 9. And finally 6, which is the same one here. Same as the 12. And then finally we're on to 7 and 8. Let's put that in a little bit clearer. Set the last one down. There's 8 and finally 7. So as you can see there, the shape we're making, I'm going to connect all these up in a sketch. So very lightly sketching my curve. Three, 4, 5, 6, 9 to 8, 8 to 7 will go down and will lift back up. And now that I have the curve, I'll sketch that in. There we have it. There is the cut shape of what looks like to me like a cone. If I was to actually get the cone, I'd assume then, obviously from where that point would go up, that point would go up, I assume the cone then would look something, and this is just me putting in the tangent as I imagine it would be like, something like that there, and it would continue on. Okay, and that's just kind of how it's after being cut then by the oblique plane. Okay, that's the cut surface inside there. Okay, so you have it, guys. Just zoom out there now. That's sheet 8.1, exercise done there based on the oblique plane. Point location method up here. Once again, point location, but what was important was how we also found the vertical trace. In this one here, we had to use the true inclination of the oblique plane in respect of the vertical plane, which they told us was 60 degrees. When it's the vertical plane, you'll get the angle in the plan. Okay, when it's the horizontal plane, you'll get the angle in the elevation. Okay, so it's kind of vice versa there, but it's the same method applied on both of them to locate the other trace. Once we had the trace, then it was easy enough to do the point location exercises. Okay, so that's the problems completed there, guys. Little tricky questions. I hope you found those helpful.